Thank you, everyone, for joining us. I'm Caroline from Equalum. We today are going to be talking about driving real-time operations with change data capture. We've got Kevin Petrie here from Eckerson and Nir Livna from Equalum. I'll introduce our speakers today. Kevin is the VP of Research at the Eckerson Group, and for 25 years, he's deciphered what technology means to practitioners as an industry analyst, writer, instructor, marketer, and services leader. He's launched and built and led a profitable data services team for EMC Pivotal in the Americas and EMEA, and ran field training as a data integration software provider at Attunity, now part of Click. He's a frequent public speaker and a co-author of 2 books on data streaming, and Kevin is also a data management instructor at eLearning Curve. So Kevin, thanks for joining us today.
Great to be here.
Nir is our founder and CEO at Equalum and a thought leader with over 20 years of experience in big data architecture and performance. He's led project management at Quest Software, which was acquired by Dell, for all big data products. And Nir also led big data architecture projects at the Israeli Military Intelligence Unit, equivalent to the NSA. You can ask him about that later. He is currently a member of the Forbes Technology Council, and Nir, we're glad to have you too. So we do always enjoy having a live discussion format, which it'll feel today. If you do have questions during the presentation, we just ask that you put them into the Q&A feature at the bottom of your screen, and we're going to try to hold those questions until the end of the presentation. So gentlemen, I turn it over to you.
All right. Thank you, Caroline. Really appreciate it. So I'm going to set the table with a few comments to frame the discussion, and then Nir and I are going to examine some questions that we're posing to one another in terms of where, why, and how to use CDC in order to drive real-time operations. So really looking forward to the discussion. If we take a view of recent history, over the last 5 years, as we know, there's been a real push with enterprises, both early adopters, fast followers, and now even late adopters, to describe business situations, correlate data points from a lot of different places, and use that analysis in order to make predictions of events, of business opportunities that might address buyer opportunity, or I should say buyer behavior, fraud risk, operational risk with mechanical equipment. And a lot of the sources are relational databases, application, IoT sensors, different files. So data teams are starting to migrate these analytics workloads from on-premise to the cloud. And that shift is well underway, as we know. Things are getting very interesting now because 2021 onward, we've seen a huge shift with our consulting clients, practitioners, and also vendor innovation, which Nir's going to be talking about, where analysts and applications are now consuming data. And they're actually starting to prescribe and even operationalize action to take based on data insights and real-time insights in particular. So this requires real-time data integration for analytics and for applications workflows, and in some cases, integration of analytics with application workflows. Cloud and multi-cloud architectures are continuing to rise. As we know, COVID hit the fast forward button on cloud modernization, cloud migration, and so you're seeing more cloud native operations that are driving this as well. So if we kind of chart what's happened, and you go ahead and build this out, Caroline, over the last 5 years, obviously the date ranges here will vary, but if you move up the stack, you can kind of visualize how you're moving from historical measurement and description to understanding and starting to ask new questions, identify new opportunities, to actually forecasting, predicting, recommending, and instructing, prescribing action for customers, for salespeople, for other stakeholders. And then there's actually operationalizing those insights, where you've got applications that are automatically ingesting some insights and putting that into a workflow, taking humans out of the element. So over time, analytics are becoming more forward-looking, more wide-ranging, more exploratory, and more automated. And the 2 specific scenarios that we're going to talk about are driving real-time operations by prescribing actions for humans to take or recommending them, and then also operationalizing the action itself. So a lot of use cases, a lot of examples out there, and I'm looking forward to Nir's perspective when we get into the discussion in terms of what you're seeing among Equalum customers. There are a number of different use cases. I could probably have 20 different squares on this chart, but some examples are customer recommendations, fraud detection, preventive maintenance, robotic process automation, and then intelligent process automation, which takes robotic process automation and starts to apply AI to guide those processes. So if we look at specifically, for example, in the area of fraud detection, we've worked with a very large payment processing firm that uses machine learning in order to assess, to score merchant transactions in its payment processing system as data flows through using Spark on top of Kafka. And they are assessing on a real-time basis when a merchant wants to process a transaction based on a number of different data points, what the risk of fraud is. And it's a classic case of needing to strike a balancing line, because on the one hand, you always want to stop fraud. On the other hand, you don't want to stop and frustrate a merchant that wants to process a valid transaction. And you're never going to know, based on this algorithm, precisely which scenario you're dealing with. So you have to strike a right balance, and you have to calibrate on an ongoing basis to make sure that your machine learning algorithm is doing the right things. So this organization is using change data capture in order to understand three types of decisions: whether to accept the payment card, what the level of transaction risk is, and then the cost of processing it. And so they're going to do this and bake this into algorithms that make inline decisions and then retroactively assess those. They're doing this supporting more than 40 million transactions per day and peak periods of more than 1,000 per second. So there's a lot of volume here. There's a lot of money at stake, and you need to get it right. And as we're going to show with a number of these cases, you really can't do it unless you have change data capture. We'll talk about what that means architecturally, but essentially, change data capture lets you capture data in very small increments and not repeatedly copy unchanged data. So it's a much more efficient way to stay in sync on a real-time basis. And it's absolutely instrumental with use cases like fraud detection. There's another great example here, which is basic operations. And in fact, customers increasingly need real-time data views into their accounts. And they also need to be able to provide or perform real-time basic analytics. So there are a number of very large financial firms. I'll describe specifically one scenario. I can't name them, but it's a household name. And what they're doing is helping you use cloud-based microservices to modernize applications. They're extracting data from an on-premise mainframe and they're publishing it to AWS. And in doing so, they're distributing workloads and mirroring data across regional data centers so that if you're a high-value client and you travel a lot, wherever you are, whatever theater of the world you're in, you can get a real-time view of your data and you can perform basic analytics on that to model retirement scenarios and other things. So it's basic plumbing, but it's absolutely pivotal and critical to meet modern customer expectations. And a lot of it's enabled by CDC. So another scenario that we're looking at, and there's actually a great trade publication article on this. It doesn't talk about CDC, it doesn't talk about technology, but it's just a fantastic example of how organizations, run-of-the-mill, or I should say traditional belt and suspenders organizations, are getting a lot smarter about the actions they take to produce things. So Harley-Davidson, they perform preventive maintenance in order to minimize factory damage from oil corrosion, from heat, and from vibration. And they're using advanced IoT sensors to predict and forecast performance in order to keep things running. And what they call, their goal is near zero downtime or breakdown status. And they can do that because rather than having plant managers go and do visual inspections, they're now able to operationalize some basic checks for wear and tear on different machines. And if there's any alert, any sign of undue wear and tear, that'll automatically trigger the collection of a lot more data. It'll trigger an alert to the plant manager so that on a dashboard, they can sit there without getting out of their seat. They can start to get a lot smarter about what the situation might be and use that to take more informed actions. We talk here about sales opportunity analysis. There are a number of examples here. Organizations can use AI and ML in order to identify customers that are at risk of leaving the bank. And so there's a large multinational bank that takes 3 years of historical data, deposit balances, transactions, product usage, revenue, credit information, and so forth, and brings it into a unified federated image across their repositories. And they're applying ML to that consolidated data in order to predict customer churn. They'll generate a score based on accurate customers. Customers above a certain score, above a certain threshold, are going to trigger an automated alert to salespeople, among others, about how to intervene and take smarter action in order to prevent that customer from leaving the organization, or in order to reduce the likelihood that they will choose to leave. So these are a lot of examples, and you can see that all of them are going to benefit from having change data capture that's going to create incremental data updates and synchronize data on an incremental ongoing basis. So we can go ahead and build this out. So just to look at the architecture real quick, I think we understand the aspects of this, but essentially you have operational applications, relational databases, files, and so forth, and they capture the operational status on an ongoing basis of an organization. And what you need to do with the data pipeline is ingest that data. You need to extract it, capture it, ideally stream it as an increment with CDC to a target. Along the way, and many times, you need to transform that data. You might need to filter it, combine data sets from two different sources, format it, create a common format structure, or cleanse it. The more of that you can do in flight, the less you're incurring operational burden on a cloud-based target. As we all know, there's a lot of pain related to cloud compute costs right now. Once the data is delivered, you might be delivering in a batch. More likely on an ongoing basis, you're going to be delivering a CDC increment, and that's where you can append and merge your data. And all this needs to take place with data, with schema, and with metadata. You also need the ability to figure those pipelines, to execute, monitor, and orchestrate. This is taking place. Yes, a lot of operational sources are on premise, more and more of them are on the cloud. And so what you've got is a lot of hybrid cloud and multi-cloud platforms across which these pipelines need to operate. So that's the foundation we're starting with. And what we're predicting is that if we look ahead for the next 5 years, we can go to the next thing here. So there's been this move over the last 5 years from batch to streaming. And what's happening over the next 5 years is that you've got this enablement of real-time operations, a convergence of analytics and operational workflows on hybrid cloud and multi-cloud architectures. And I've called out a couple of aspects of this to show what's changed. One is on the target, of course. Now we've got operations, which might be a direct recipient of data. Oftentimes they are. They also might be a direct recipient, even an automated recipient of analytical insights that are being performed. The transformation tasks of filtering and combining, and then the delivery task of merging, are all things that become really critical when you talk about real-time operations. And those things benefit from change data capture. So I think we've got one more slide here. Okay. So I think the key point, I've made it along the way here with the architecture, is that change data capture, as it says, capturing and delivering data, creating it in live increments, you're handling things much more efficiently. Even if you don't need real-time insights, you should strongly consider getting rid of the batch process, which is repeatedly copying unchanged data, because that can create bottlenecks in your operations and your analytics. So change data capture can drive real-time analytics and operations. So Nir, I'm going to invite your thoughts on what we've walked through, and then we can also talk through these questions. I'll put some questions to you, provide my 2 cents along the way.
Sure. I also want to just put a few points on the slide with the architecture for a minute. So holistically, when I look at this slide, it actually encapsulates tons of very complicated architecture decisions. It sounds like everything here is like, blending together in a nice, simple environment, but the amount of permutation, the round of dimensions in this architecture slide is actually pretty big. If you think about it, holistically, there are two main routes for why you would drive data and how you would use data. One of them, as we said, is the analytics. So you do some streaming data integration for the sake of analytics. The other one is doing stream data integration for the sake of operations. So that's an operational use cases. Now, the holy grail, honestly, to some degree, is being able to do both and have them actually benefit each other. So that way the operations actually benefits from analytics in real time. So think about if you could actually take the data, do some real-time analysis on it, and actually drive an operational outcome, that becomes the holy grail of the solutions. Now, in order to actually be able to do this, you actually have to support quite a few things. But if you only looked at analytics by itself, you would have to consider ELT scenarios and ETL scenarios. So either some sort of real-time replication scenarios with transformations on the target, or you'd have to consider ETL or both, honestly. Sometimes you would even have to do some batch in between to get some of the insights. So that by itself has quite a few implications on the architecture. And then you combine with that all the needs of the operational side of things, it actually becomes a big, more important story with many more branches. But the key of all of it, surprisingly enough, is actually the CDC. One thing is to call this an incremental sort of extraction layer, which is correct on a technology level, but there's one more technology aspect of it. It actually takes transactional data and can convert it into events. So it's actually the only driver that allows you to take legacy systems with transactional data that looks at data at rest in general and does not necessarily track changes in a nice way, and then convert it into the events that are needed to then execute either operational aspects or analytical aspects or streaming analytics or any type of thing that requires events. So this actually becomes the gateway, not just because it's incremental and easier to handle in terms of volumes, but also because it converts data at rest into data in motion, essentially.
Great points. Agree completely. And the notion of a real-time event stream is a very useful way of looking at the world in a real-time operational business environment. The more you can look at a database as a stream of events, the more you can start to really operationalize those real-time insights. So agree completely. What symptoms indicate a need for change data capture? I'll provide a few thoughts on here just in terms of using the lens of real-time operations in particular, because that's what's new and that's our focus here. But from my perspective, and then I'd love to get yours, Nir, if you have business managers that are in pain and vocalizing that pain about needing real-time insights, about experiencing delays in terms of their operations or their decision process, that's a good signal. And in a lot of this, as we go through the best practices, I'll talk about the need to listen to business managers. If you've got within the IT organization, data engineers that are struggling to meet latency requirements, to meet throughput requirements, and meet SLAs with batch processes, that's a very good indication that you need change data capture as well. So those are, I think, the two key points I'd make in terms of identifying symptoms that change data capture might be something to consider. Nir, what are your thoughts?
You know what? I'd even probably go to the basics here that says, hey, even if I don't have a real-time use case per se, like the ones we showed, like fraud analytics and stuff, I still want to see data that is fresh, that comes right now. I don't want to see data that is 3 days old or a week old, because honestly, my business is moving fast enough and I want to ensure that I actually see the real picture. So I can tell you there's a lot of risk at seeing data that is a few days old or even a few hours old sometimes. So on the business side, that's the basic. I mean, on the technology side of things, CDC is the gateway. Forget the fact that the overhead on the operational systems will be much more limited and almost non-existent for any system that is a legacy out there, rather than doing a big batch every now and then. It's actually the only way to extract incremental data from those systems. And that's the biggest problem. The need for change data capture is there if you're not Google. If you haven't built this amazing microservices, everything talks to everything type of architecture, and you don't have legacy and you don't carry 50-year-old IT. And the reality, unfortunately, is that 95% of the companies are not there. They carry legacy systems, they have their old databases or applications or their SAP or whatnot. And extracting data in real time from those systems is unfortunately not as easy. The only real practical way to do it is either CDC or just completely rewriting your application, which nobody's going to do, the reality is. So, coupled with the fact that all the new projects, the data lake projects, do require real-time aspects, real-time streaming aspects, real-time analytical insights aspect for machine learning or AI, I think CDC becomes a no-brainer. I don't see any organization, again, that is not necessarily a Google or a Facebook type of architecture that will be able to actually do all these outcomes without starting from a CDC point of entry.
Agree. And I think that if we look at the Fortune 2000, to your point, Nir, over 90% of them are not cloud native. And they need to modernize what they have, which in some form is going to persist. And that's often traditional workhorse applications, SAP, mainframe, various Microsoft applications. And all those applications on those traditional databases need to have their data published to something new as part of a data modernization effort. And so what we see a lot of organizations doing is using change data capture to, in a very non-disruptive way, extract real-time incremental updates from those core operations and publish them to a streaming system like Kafka. And the nice thing is that if you publish to something like Kafka, you can maintain a microservices environment. You can have that intermediate broker that enables different microservices to be loosely coupled, but autonomous and independent with one another and modular. So if one microservice goes down, the others stay up. And I think that that's the kind of thing CDC is the starting point to inject operational data into those environments.
And we're seeing some good questions on the Q&A. I just wanted to say that we're seeing those, and we'll definitely try to answer those as well.
That's great. And so let's go to the second question here. What are examples of tangible business problems that CDC addresses? So I approach this as use cases. We talked about a number of examples before. What I would add to that is that CDC also helps mirror and synchronize workloads, mirror data and synchronize workloads across highly distributed, heterogeneous, cloud-based architectures. There are a number of cases in which organizations that are global need to have data mirrored across different regions, and they need to have it all in sync. And CDC can enable those scenarios. So that's additional business problem that CDC can address, which is that your global customers can maintain data availability at very low latency due to the mirroring that you're enabling. So next question here, what does it take to implement and integrate CDC for real-time operations? So a lot of the best practices that we talked about here apply to multiple technologies. And if we look at this as kind of a process flow, the first thing to do is to ask your frontline business managers about where they're in pain. The easiest thing to get budget for and to gain organizational acceptance of is solving pain. Talking about potential upside, that's great too, but it's not as easy for a first project. So if you start with pain and it's business pain, then you can start to categorize your requirements. You can gather and prioritize requirements according to their business aspect and how solvable they are. Is there one choke point, or are there multiple choke points? Is this an isolated problem, or is it something that pervades an organization at bunch of different levels? So you want to have an impact, but you also want to find and prioritize the lowest hanging fruit, because if you tackle a project where it's a departmental bottleneck related to one application or one use case, you want to get a quick win there, because then you're going to gain the business support to extend your use of CDC throughout the organization. So you take that higher priority business requirement, translate it to technical requirements in order to identify where and how CDC can fit within your data architecture. Then you can build a high-level plan to address that and future use cases, propose it to business leadership, and then you need to assemble a team that's going to figure out how to put this into place. Ideally, you're going to get an executive level sponsor. You're going to get someone within the data engineering community, maybe a data scientist if these are advanced use cases. Maybe it's more of a BI analyst on the consumption side. And if you're automating the insights of what you're doing, then you might well want an application developer. So with this cross-functional team, you're going to start to run through your tool selection process, figure out what your tools are, and then the critical piece is, as you execute, really look at people and process, not just tools. So that's kind of a view of the whole process that I think can make sense to fit CDC into your organization. I'll pause, and Nir, would love your thoughts based on the work that you do with enterprises.
You touched a lot on the operational/business side of things, of how to kind of do this, from a method perspective inside the organization.
Yeah.
I'll touch the technology piece, because it's actually funny from the technology piece, you don't have to think too much about integrating CDC because CDC is actually the gateway to allow you to do the data integration in the first place. So it actually is, you'll find CDC becoming very seamless relatively to your operational systems and, IT in general. That's the beauty of CDC, is that it allows you not to do those changes, those big architecture and application changes. The actual implementation of CDC, assuming, of course, you choose the right tool or you implement it the right way, should be very, very seamless to the business itself and to the IT. You still have to choose the right tool. You still have to know what you're going to do with the CDC data once you're actually extracting, because remember, CDC is just the extraction layer. And then the question becomes, okay, what do you do with it? Which use case do you actually run through this? Do you use this for analytics, for operations? Is it an ELT use case or ETL? There's a lot of thought process that needs to be done on data integration level in general. But integrating the CDC component itself is actually pretty straightforward. Just choose the right tool. Make sure you're doing the CDC the right way. I mean, you guys will be surprised. There are probably 7 ways to do CDC right now. In general, there are tons of ways you wouldn't even believe exist. So just make sure that you're picking the CDC approach correctly, because bad CDC choice can lead to a lot of problems, can lead to bottlenecks in performance, can lead to insane overhead on throughput. There's some guy talking here about native, Microsoft CDC. Good example of a badly implemented CDC, unfortunately, on the Microsoft side of things. But I'm sure, in big volumes, we're probably having some real issues there. So just choose the right CDC technology, the approaches. I mean, anything that will go and be as lowest overhead as possible while giving you the best throughput. The combination of that would probably be the right place to go. But that's from a technology perspective. What are the 7 ways to do CDC? By the way, I just finished and somebody's already asking. I mean, there are tons of ways. Generally, you can go all the way from APIs to actual reverse engineering of code, which can be, for example, database binary read of transaction logs, or if it's an application like SAP, actual reverse engineering application level code. There are network sniffing approaches. There are database triggers for databases. There's tons of ways. And each one of them encapsulates million of things that you need to consider. And you need to know what you're doing. It's also not generic. It's not like you got 7 and they fit all data sources. Each one of them will behave very differently in its source. You need to really understand how the CDC works for the method you chose for that particular source, if that makes sense. And beyond that, we can spend hours just on this.
It's a great segue into the guiding principles question here. Maybe I can start with just product evaluation criteria, which is to build on your comments, Nir. Prioritizing ease of use is critical. The more you can automate and reduce or even eliminate the burden for data engineers and ETL developers to script commands, the better. Some prefer to, but in a lot of cases, they can automate the easy stuff, focus on the hard stuff, or ideally automate everything, because then you're reducing burden for the really busy folks. You're freeing up maybe data scientists or other types of folks to perform basic data integration tasks. So ease of use, I think, is a critical product evaluation criteria. Another you touched on here is source impact. The more you're not invasive to the source workload, the better. And then a final one would be breadth of interoperability. One of the common themes is that enterprises need to plan ahead. So they're not just trying to buy a CDC solution to go from point A to point B or points A to C through A to C today. It's really, what can you do to meet A through F or Z today and in the future? And so if you can standardize on something that'll meet your future needs, all the better. So those are some thoughts on product evaluation criteria: ease of use, breadth of interoperability, and source impact. So in terms of guiding principles, I have a few thoughts and I'll share it, and Nir, would love to get yours before we go to Q&A here. I think the guiding principles and pitfalls and early lessons go hand in hand. And some of the key points here are that organizations should, I talked about low-hanging fruit, identify pain today, figure out how to alleviate that pain, start small and achievable, and then demonstrate value and then go broader. Those are the best ways to navigate an organization, get the necessary budget, the necessary organizational support to do what you need to do to go to more of a real-time operational environment. Another critical one is do no harm. When we're talking about real-time operations, these are operations that in a lot of cases are spending money every day, saving money, or bringing in money every day, and you really can't get in the way of that. So what we find in terms of real-time analytics and operational scenarios is those that do no harm and take a very incremental approach to the changes they're making. So that often means very basic analytics use cases, making small changes to workflows. If you can make a small change to the types of recommendations you take to e-commerce buyers on your website, you could potentially realize a big impact. You could also send things sideways and alienate customers. So you need to get it right, and you need to start with small changes, which means very basic analytics algorithms that are being integrated into operations. Those are some of the thoughts we have on guiding principles. Another is just to be sure to listen to business pain more than IT pain, or as much as IT pain, because it's the business that you're ultimately trying to enable. And there are a lot of science experiments that don't necessarily help the top or bottom line. Nir, thoughts on guiding principles?
Yeah, I'll touch on the last one because it's important, I think, and then I'll go to a few more. But the part where, we're talking about this is not to say that tomorrow you're going to start replacing all your 5,000 Informatica batch flows with the real-time streaming, architecture. That's not how it works. First of all, the newer use cases, the data lakes initiatives, the newer modern data warehouse initiatives, that's where you should put your first piece in. And I think you should ensure that you can build for the future and slowly potentially migrate, not necessarily all of them, but some of the use cases. But I think it's more about, how does the next step of, analytics and operations in your organization look like? And what do I need in terms of the architecture to support that? It does not mean I'm going to start replacing everything I have unless there's a very good reason to do so. For example, if you're hitting performance bottlenecks or anything like that. That would be sort of, the initial piece is just make sure you use greenfields, make sure you get those quicker wins. I think on top of that, ensure flexibility. Because of what I just said, it's very important that you create an architecture that is flexible enough to ensure that you can meet all kinds of use cases. And you plan for today, but you also plan for tomorrow. You plan for the known, but also for the unknown. So make sure that you're actually thinking about, hey, some of this data is going to need to be ELT'd, some of it is going to need to be streaming ETL, some of it going to be batch ETL, some of it will be operation integration, application integration type of use cases. How do I put an infrastructure in place, an architecture that will actually allow me to support all kinds of use cases, all kinds of scales, all kinds of SLAs? And I think ensure the flexibility. I often see this big problem, and it comes to the third point. A lot of customers, they think, okay, CDC, I'll just replicate the data to the other side, do some sort of an ELT story, and I'll be done with that, and everything will be great. And then they pick a tool that can do replication, and that's great, even works, and implement it. But then, okay, now I need to do transformation. So what do you do now? Do you buy another tool to do transformations? But if you buy that tool, how do you actually publish CDC changes into that tool in real time and ensure that tool can take it in real time? So it becomes a problem. You're kind of buying two things that are not really connecting really well. You're also spending double amount of money, and cost of ownership goes high. Supportability becomes a problem, and then you buy more and more tools for more and more use cases. So I would say focus on trying to get a multi-model approach. Try to get something that looks at CDC as the start, but also can give you all the use cases afterwards, which is can do that streaming ETL, can do that streaming ELT, can do even batch if needed, can do all of it together. Not because you're going to replace everything in the organization, just because you never know how the business is going to react and what will they need from you. And I think if you build it smart from the get-go, you won't find yourself with 5 tools after a few months, and you'll scramble and trying to solve those pieces and get them to stitch when they really don't.
A great point. The classic problem is buying a fancy tool that is really easy to use, but it only addresses a few use cases, and it doesn't replace anything else. And so in the end, you've got two tools to use, and your overall management burden goes up. So agree, standardizing on fewer tools is absolutely critical, and not being afraid to phase out old stuff. Caroline, do you want to share the questions here?
Sure. So the first question that came in was from Dovile, which was CDC versus APIs. What's your view? My company is investing in ESB, a data integration platform, and it kind of competes with CDC. What are the benefits of CDC versus ESB? Yep.
Yeah, that's a nice one. Okay, so ESB, Enterprise Service Bus, guys. So the idea is that, there is this notion in the world, it's been out there for years, basically, but it's almost as if it reminds me of that Google story that I told you. It's like, let's build a service bus and have it handle sort of all kinds of consumer people that will consume the data for analytics, for operational reasons, for alerting and notifications, for a whole bunch of things. It's a very decent approach to kind of centralize your data strategy around some sort of scalable piece that will then be a dispatcher, sort of. The only problem with this is that it does not necessarily it doesn't solve the problem, because, okay, let's say you have a service bus, which is important, but how do you get the data into the service bus? So what, do you assume that you have REST API integrated? You said here in the question, CDC versus APIs. If all your applications speak through API and speak through microservices type of architecture, great. Use it. You're in the fortunate 5% of the world where everything is kind of stitched really nicely together and you don't have to worry about CDC. But the reality is that, unfortunately, most of your applications in the organizations, maybe the ones, I'm not talking about the web services that will publish some API, but a lot of those internal systems, operational systems, unfortunately, CDC will be your only way to actually extract data into your ESB. So again, ESB solves a very small part of the problem. By the way, it does not only not solve the CDC part or the extraction part, it will also most of them will not allow you to do some crazy transformations or aggregations or do some very heavy ETL stuff. So again, then becomes the question, where do you do that? So it's almost as if ESB is part of the piece to some degree. It's an essential piece. I believe everybody, this should be the piece of inside the pipeline of everybody. We use it internally in our tool even, but it's just part of the piece. There are things around it that you need to stitch. And then it becomes a question, do you want to do everything, do it yourself? Do you want to buy a tool for CDC and then have it push data into the ESB and then have another transformation product on top of it? Then you're again with 5 products. So again, ESB, very recommended. CDC versus APIs. If you have API only approach that will work for all your sources, you are a very fortunate guy.
Well put. I would just add that most data consolidation efforts end up increasing the number of endpoints within your organization rather than decreasing. And so you should expect to be hosting a multi-lane, multi-directional highway for the foreseeable future. So standardizing on one platform or fewer platforms that can handle all your scenarios, all the better. And that just underscores what Nir said about APIs often being insufficient.
Thank you. Let's go to the next one, which is, are there market standard CDC tools? For MS, we use native CDC functionality, but maybe there's a universal tool?
Well, there's no universal standard. There are certainly some tools, and I'll let Nir speak about Equalim's approach, but there are certainly some tools that seek universal coverage. I'd say Equalim is high on that list. And there are definitely a number of platforms out there that have some native CDC capabilities. Oftentimes, they're not able to handle the bandwidth or the throughput or the latency requirements of organizations. They're often not easy to use. And rarely, that by definition, they're going to be more native to that particular endpoint. So they're not going to provide the broad platform coverage that we're talking about here.
Yeah, I would say there's not a universal way to do CDC to every source in the world, no. But there are tools that pride themselves, we are one of them obviously, that pride themselves on being able to do CDC from many, many, many sources in the most efficient way. And that's critical because, again, if you told me there's a way to do CDC from all the sources in the world, using one approach, I would probably be very pessimistic because it doesn't make sense. Each source has its own uniqueness. The journaling mechanism of each source is very, very different. Sometimes they have, by the way, sometimes they don't have at all journaling mechanism. You cannot even CDC at all. I mean, this is rare, but I would look for the product that knows how to do this very deep and understand the source. But it wouldn't be, you talked about here on Microsoft CDC. There are like 4 ways to do CDC approaches from Microsoft alone. A whole bunch of replication ways, and I won't go into the details here. And that's excluding the other options that I just shared, like the other 6 or 7 other options. So again, it's like there's not one size fits all sort of story. I think if MS CDC works for you, great, then that's great. But even if it does work for you, how do you ensure exactly one semantics is being handled correctly through the cluster? There's so many other things on top of that CDC extraction that you need to worry about. Again, so I don't see something standard. I do see tools that are comprehensive enough to handle many, many sources. Yeah.
So in the interest of time, I want to take a couple questions that we have in here from various attendees at the event. So we do want to answer all of them. If we don't get to answer them today, we're happy to respond also by email. But another question is, I've heard the challenge with streaming and integrating data can be eventual conformity. How do you handle the people change management part of moving org from daily batch expectation to streaming when they want streaming data to reconcile match their batch expectations?
Yeah, I'm just curious whether I'm answering those 2 questions quickly before and keep going. I just feel like I'm missing questions and I feel bad about it. But okay, I'll answer this one. So how do you handle eventual conformity? I think you have to look at the use case. I mean, first of all, it does not mean the fact that you're CDCing and you're converting transactions into events does not mean that you need for that to reflect on the endpoint of things, on the consumer side of things. You can take the data, you can decide sort of, okay, this is the point where I'm getting to some sort of consistency, and then I'm showing that. So yeah, it sacrifices some latency because you're waiting for a certain point, but you are showing something that is much more familiar to the batch people. But I think at the end of the day, if you do this right and you, for example, ELT the data, you can reach to the point where it feels like it's reconciled to some degree. Of course, changes keep coming. But if you do it right, you can publish it in a way that will not hurt the outcome for your managers. I think the managers also have to realize that, hey, they're getting real-time data. And the nice part about real-time is it keeps changing, that the reality changes in real time. You don't have to show it in real time. You can show it every 15 minutes and still do CDC. So again, don't focus on CDC as, if I went streaming, that means I'm doing streaming analytics. That means I'm doing something that runs on events. No, it doesn't have to be. You can do streaming analytics on the events. You can try to look at the events as sort of a window type of implementations, but most of the people don't do that. They use the CDC to do the ELT, to do the ETL, transform the data, get it into a position in the data warehouse and lake, and then they show a data at rest version of that data. So it's no longer data in motion, and therefore it's not going to feel like it needs to be reconciled or it's inaccurate or anything like that. I hope that answers.
And then next question being, are there any open source CDC options, and do you need to implement a failover solution for CDC?
There are CDC open source options if for certain sources, limited amount of sources, if you are willing to sacrifice certain things in the process. So like anything in open source, certain things are implemented, certain things are not. It is what it is. You can find those online. I would be respectful of putting names of anybody here. But you can find those online. You'll quickly get to the limitations. Maybe it will be enough for you. Maybe it won't. It's up to your use case, how strict you are about ensuring your data is correct. Performance, SLAs, a whole bunch of things like that. Yeah, you could potentially find something open source if you want.
Yeah, and I mean, there are pockets of innovation across the software industry where open source is creating a vibrant community of contributors where you have a big backer on the corporate side. That's not the case in CDC. And that's a place where you need it because you got to have that broad interoperability and you got to have that ease of use. So there might be, to your point, Nir, cases in which open source CDC is good enough for narrow, simple use cases, but rarely does that scale.
Do you need to implement failover solution for CDC? The answer is yes, of course, like anything in life, I feel. But that's a topic by itself. It's a really big topic.
And then I think the last question we'll do, the others will hold till the end, would be, can you list out the top 3 non-negotiables with regard to best practices when implementing CDC for it?
Beautiful question. Honestly, a question that I would, if I had the time, I would respect it by taking a couple of minutes before I answer this. But out of the top of my mind, I would say, first of all, don't negotiate the depth of the CDC solution. I'm sorry, it feels like I'm going to start trashing the open source CDC now. But again, you get what you pay for, and you're not paying for it, which means you're getting a certain level of CDC. I'll give you an example. In Equalum, we do, for example, Oracle binary log extraction, which means we're going to the read log. We reverse engineer the read logs physically, like the binary data, and then we are actually using that. That gives you performance benefits that is probably 10 times better than something in open source would do, by the way, which will use LogMiner. That's how it would do it on Oracle. You know why? Because that's the easiest way to do it. It's an API. The problem with LogMiner is it will only allow you to execute on one core, one CPU. And the problem is, one CPU is just not going to be more than 10,000 events per second. So as long as you're behind that on numbers, you're good. If you want to go more than that, you're going to hit bottlenecks. It's also going to hurt you in terms of like performance overhead. So again, the depth of that CDC solution is very, very critical. So I would not sacrifice there. The second thing I would not sacrifice the multi-model approach. We're seeing here in the background some of this. You see how there is some replicate batch ETL and streaming CDC transformation, or I would call it streaming ETL as well. Those use cases, you need to find one tool that does all of it, ideally, if you can, because the reality, if you don't, then again, you're stitching, you're buying more products than you need, you're doing a whole bunch of things that you shouldn't be doing. So you need to be able to support transformations. If you have a CDC tool that just does replication, I would heavily go against it. I got to be honest with you, unless you have a streaming transformation solution that can somehow magically inject into that CDC replication tool and stitch it and work perfect harmony together. And it comes from the same company as well. If you don't have all of that, then I would definitely try to avoid that and at least get the streaming ELT and ETL tied together. And I would also prefer it if there are some batch ETL capabilities, just because sometimes you want to really blend streaming and batch scenarios together in some way. So sometimes you're using historical data inside a real-time event stream. So while you transform, you want to do some cross-reference joins with batch data. There's a whole bunch of reasons, but I would try to get all of them in one tool if possible. The third thing, I would say flexible, multi-cloud, multi-model approach, which means you certainly can do it on-prem, you can do it multi-cloud, you can do it hybrid. Those are the 3 out of the top of my mind. There's probably a million more and maybe just as important, but those are the 3.
So we'll hold these other questions until the end and we'll continue here. But thank you. We see the questions in the Q&A and we will get to those at the end of the session here.
Perfect. Okay, so I'll use a few minutes to kind of take this discussion, tell you a little bit about Equalum, but through a lot of what we talked about, because at the end of the day, we're all engineers. We're not really sales guys. We're engineering what we feel should be the market. And I talked about this replicate batch ETL, streaming ETL scenario, and how people buy 3 tools to handle this. As you can see, replicate and the streaming ETL both use the CDC as a gateway. But again, it sometimes can be 2 different tools, and there's no reason for you to do that because honestly, it just creates a lot of financial overhead, operational overhead, and whatnot. Monitoring, maintenance, clusters. If you're using modern technologies, you're in a cluster environment. So again, managing those clusters can be awfully hard as well. So I would definitely think about how you can do this together. If you can go to the next slide, it's kind of how we architected a lot of what we do. So what you'll see here, one platform that fits all, multi-model, but does not sacrifice, and that's critical. We always ensure that we don't sacrifice the depth that we go through in each one of those use cases. So we ensure that the CDC is a real, true CDC that is going to be very, very performant. And we also ensure transformations. And we also do batch pretty well, about 10 to 15 times faster than batch approaches. But it doesn't mean you're going to, as I said, you're not going to be replacing your entire organization batch process with us. That's not the intent. But it allows you to do all the three things together. It runs on top of modern open source technologies, Kafka, Spark, all these technologies that really can handle unlimited volumes of data, which is another big limitation of legacy solutions. You often end up with an engine that was built in the 80s, and there's limitations. It is what it is. So we are giving what we believe to be the dream of modern data integration by allowing you to do that CDC from all kinds of places, databases, applications, files, web services, whatnot, if it's your SAP or your Salesforce or your Oracle or your whatever, it doesn't matter. There's the many, many sources that we support. Doing a true CDC, taking care of exactly one semantics end to end, including through the clusters, through the Spark, through the Kafka, which we orchestrate. So all the processes that are being done are actually running on top of these technologies. So Spark is executing our workloads and Kafka is storing. That's our ESB, by the way, for the guy that asked the question about the ESB. So the internal Kafka kind of acts intermediate ESB type of thing. But all this is orchestrated, which means you're not managing the Kafka and Spark clusters. You don't have to worry about failovers. Everything is taken care of for you. And then you get the ability to do transformations in real time, in streaming, or in batch. And all this is happening on the one platform, on the one UI. It looks the same. The end result, you can replicate the data for ELT scenarios. You can append the data. You can merge the data. And you can also execute things on the target as well while doing so to complete that ELT story. So all of that runs on-prem, cloud, hybrid, multi-cloud, anything you want. And this platform gives you the best way that we believe is to build pipelines these days under a very simplified UI. So if you go to the next slide, this will be very familiar to people doing ETL. This is how you do ETL in many of other legacy tools out there, except this runs on Spark and Kafka. This runs in streaming. This runs in batch. You can actually execute this any way you want. And we do have a very simplified UI for replication, which we don't show here, but we can definitely show you in a demo. But we got replication groups and everything that is needed for replication use cases to blend together with this. So you're getting really the most efficient way to execute stuff. If you look at the top here, you'll see classic and replication on the top side, on the right-hand side. That's where you can switch to replication mode, get working on replication stuff. These are the sources and the targets, and a lot of the flows and all the stuff that we're doing. You can monitor the platform directly from here. We got hundreds of monitoring metrics and alerts. And in general, it just works. It's a big data in a box sort of story. Streaming integration, modern, everything powered by CDC. So a lot of the sources, even the S3 buckets here are CDC. We CDC directly from S3, Postgres, Oracle, MySQL. There's tons here. There's even some snowflakes here. So all of this is in one platform that essentially can scale to any size, have clusters of hundreds if needed. So all of this comes together. That's Equalum in a nutshell.
Before we take the final questions, we want to leave you with a piece of CDC resources that may be helpful for you. This is an ebook that we've created at Equalum called Top Design and Implementation Challenges with CDC, Strategic Considerations for Successful Streaming Ingestion. You can look at this for just easily on our website right on this page, or you can download it as a PDF if you prefer to view it that way. In the few minutes that we have left, I know it is almost 3:00. But we're happy to answer the questions in the Q&A. Nir and Kevin, if you're willing to stick around and answer some of these for those who want to stay. Do you want to just go through them, Nir?
I'll go through them by how long it takes to actually answer them. Can Qualum replicate from on-prem MS SQL Server to ADLS? Of course, the answer is yes, absolutely. I'm more than happy to show you this offline. Does the Qualum need some agent software to be installed at the source and the target? The answer is no. No, if you don't want us to. We can do that if you want. If there are, for example, sometimes you want to save networks, so you want to filter data before it actually goes to the cloud. So you can do that, but no, you can actually work completely remotely from the source and targets. This is the flexibility I was talking about, right? Because You don't know if tomorrow you're on cloud, today you're on-prem, maybe tomorrow you're on multi-cloud. You need to have that flexibility. So we offer you that. But no, you really don't have to if you don't want to have anything on the source or target. Does CDC enable both Lambda and Kappa architecture? The answer is yes. I don't see one of them is specifically prevalent in the other. We can go into details here, but I'm not sure the entire audience even knows what Lambda and Kappa means. So probably the Lambda, yes, maybe the Kappa, no. But the short answer is yes, it's relevant for both. Those are essentially deployment methods and resource sort of utilization methods, and CDC will work very nicely on both. We actually started from a Kappa architecture in our product to some degree. You could call that, where a lot of our metadata was also stored on our Kafka. We moved away from that at some point because of a whole bunch of reasons. But again, this works on both at the end of the day. Both will fit. Is architecture an approach for CDC on-prem versus cloud environment is different? The CDC mechanism itself does not. Sometimes there's some limitations if you're using a source on a managed service. For example, you're using a Postgres managed service on AWS, for example, instead of on your Heroku or something like that, instead of like using an install version. But most of the time will be completely the same. I think there are other things that are important when you think about on-prem versus cloud, but those are not specific to the CDC ingestion extraction layer itself. Functionality of benefits of autonomous data modeling. It's the first time we're getting this question, Caroline. Somebody actually noticed. And we run through those slides usually very quickly. Autonomous data modeling is the next phase of Equalum. I cannot go into a lot of details on this, but I will say, just to tease you, what if you didn't have to build those 150 steps of ETL? What if you didn't have to worry about all these quality things, all these little transformation, make this column be that size? What if all of this was taken care of for you? That's what we call autonomous pipelines. And we'll have a lot more information on that throughout the rest of the year, so stay tuned. Do you support bidirectional replication? Yeah, that can be achieved in Equalum as well. Yeah. Could you post the URL of book in the chat window? Yeah, Carol.
Nir, I was going to add 2 cents on two of those final few questions.
Sure.
Just one quick note on there is a shift, obviously, with a lot of software products, including CDC and data integration in general, to use a cloud-hosted model, managed service or software as a service. It's obviously critical, functionally very similar. The more you can reduce your footprint, the better in terms of needing to install software on premise. But you obviously want to make sure that you're retaining your endpoint coverage, both on-prem sources, on-prem targets, and in particular, cloud targets. And I'll actually hold off on bidirectional replication. It's a bigger topic, but your short answer is a good one. Thank you.
So how to touch base with us, we'll have Judy put all the information for you guys on the chat if you want to speak to us and see demos and whatnot. And I just want to answer one more thing. I'll try to answer. The guy asked, can you identify tools and process that can be used to verify, test the implementation of CDC through the production? I asked the follow-up. I don't know if you've seen my question. I need a clarification here. I'm not really sure what you meant, because this can go a few ways. In the minute or so that we have, if you want to answer that, I'll be happy to answer. Otherwise, we can go offline on that. All right. We are available for Azure, not necessarily as a service per se. I mean, there is definitely, there is a service sort of, you can spin Equalum through an Azure service, but that's not the preferred approach. We're less of a SaaS model. The SaaS model can be very easy entry point if your platform permits actually allowing us to store your data. Most of the cases it's not, unfortunately. And also it can start very cheap SaaS and can go very, very quickly to very bad places. That's why we definitely prefer it as a strategy to ensure that we are more predictable in terms of costs. So that's one more thing we think about. So yeah, it's available, and a lot of the implementation are on Azure. But we're not a SaaS per se. There are other tools out there for SaaS implementation if your actual sources and targets can handle SaaS sort of integration type of things. Most of the cases, it's not. Depends on the organization, I guess.
Any other questions you want to throw into the Q&A since we are here?
Here we go. How to ensure data integrity and the data corruption at the target. That's really good. First of all, you need to be able to identify that quickly. And that's something a product like Equalum does for you. If not, then you need to build it yourself. You need to create some data ops sort of practices, which, if you're doing it yourself or you don't have it in the tool, you need to ensure you got the quality SLAs, that everything works correctly, monitor the performance of your quality, and you alert. Even if you found it, then you need to reconcile it if there's any problem. The way this works, for example, Equalum allows you to do restreaming automatically for you. You click a button and it just start reconciling the entire thing for you. If you don't have that, then again, this is something you'll need to build in-house. So again, it all depends on the tool you're using, but you need to constantly ensure that your source and target are synced. It becomes a big problem, by the way, because if data flows all the time, then all the time there's going to be differences in the amount of records, almost, if you think about it. But there are ways to do it. If you think through this, you can do it by yourself, or you can use a tool that does that for you. Can Equalum replicate? It does more than just replication. So I wouldn't call it Equalum Replicator. I would call it Equalum Data Integration Platform that can do replication, but can be integrated with an event management solution. If there's any consistency, then trigger should be raised. Yeah, absolutely. So you can write to any event management system. You can write to REST APIs. You can trigger events. You can actually execute things on the targets as well if you want to actually get them to do stuff for you. So yeah, Equalum is built from start to finish on REST APIs, which means you can do anything you want. Everything the platform offers, you can do through REST APIs. You can integrate with REST APIs as sources, as targets. You can push actions to the target using those REST APIs. You can do a whole bunch of things.
Well,
a lot of questions. That's fantastic.
So many questions. Thank you guys for participating. It always makes this more fun when there are questions and people are engaged. So Nir and Kevin, as always, it's fun to have you two dialogue back and forth. For anybody, say thank you, Sapna, for coming. Oh, that's so great.
Hey, Sapna, this is our best buddy here.
And some new friends.
I'm so happy you're here. Sapna is one of our champion customers, by the way.
Yes.
Oh, very good.
And she's laughing. But for more information about our platform, you can definitely go. Thank you, Colin, for coming too. And thanks, Bilash. I hope I'm saying your name right. Thanks, everybody, for being with us today. If you want more information, you can head to our website, equalum.io. There's a lot of resources there that can help and can elucidate some of the topics we've discussed today. Additionally, we have some customer reviews of our platform that can give you their experiences with using us right from their mouth. Sapna is one of them. So please do go and check out our website and you'll be able to redirect it there. Kevin, thanks again. Nir, thanks again. Everyone, thanks for joining us and enjoy the day.
Thanks,
Fantastic.
guys.
Thank you.
Fun. Thank you. Bye.